Thank you, everyone, for being here. I'm Florenc, electrical engineering and computer science. I'm actually a computer scientist, but I teach also in the electrical engineering part and also in the computer science part. And my main research activity is related to sensing systems for healthcare. Okay, so this is a very long title, actually, but it has some keywords. So artificial intelligence, Internet of Things, in this case, it's not there, but it's of things. Sensing technologies, human activity recognition, and active and assisted living. I will try to go through all these concepts, starting from the first one, and then deeping down to all the some more technical things. And then I will show some nice, not so nice videos, but videos and things just to give you an idea of what we are doing. Okay, so why did AI become so famous lately? Okay, in the last decade, let's say. First of all, big data. So we entered the era of big data, I think, around 2008, 2009, and that was one of the first bricks that we needed to develop AI. Second thing, computational power, and this is very relevant today. Just imagine that the biggest company in the world today is NVIDIA, and that's about computational power and GPUs and other kind of computational systems. In this case, you see a data center. And then there was a lot of development in machine learning algorithms. So the basics was the machine learning algorithms. And you just see who was the winner, who were the winners of the last year Nobel Prize. Then this was also one of the main reasons, okay? So they understood how to make money out of this, okay? And we know this these days. However, there is some basic history about AI. As you can see here, we had AI in 1950s with Alan Turing, and then we started talking about neural networks in the 86, okay? And then we had convolutional neural networks in 89, and then we started having some very big use cases, actually, not specific algorithms, even if they are based on these ones here, so neural networks and so on and so forth. So AI was there since 100 years ago, basically, or 80 years ago. And this is also something that has to be very clear to us. So I said at the beginning, big data, okay? Now, if you look to this table, you see here the main breakthroughs of AI in the last years, 20 years or more. And as you see there, like this is a table that shows the breakthrough, the data set that was used in this breakthrough of AI, and the algorithm that was used in that breakthrough of the AI. And if you take a look, you see that, for example, the algorithm of the first breakthrough, hidden Markov models, was there in 84. Then this Spoken Wall Street Journal articles and other texts came out in 91, and the breakthrough came out in 94. Okay, and so for everyone. So the idea here is that, as you see here, the time distance between the breakthrough, okay, from the algorithm is around 12 years. Instead, the time distance from the breakthrough from the data set is 3 years. So this is why the data is very, very important. So AI, yes, is great. Algorithmic side is great. But without the data, I don't know if we will be talking about AI so much. Okay? So why or where are we finding all this data? There are different sources of data. Okay, so social media today, open data, web data, corporate data, and so on and so forth. And then this is my preferred part of the data, sensor data. Okay, so we started with AI, and now we will deep a little bit about the sensors. So what are sensors and what is the sensing technology? So sensors are very small components there, as you can see, okay, which perceive some physical input and can transform that physical input into some kind of electrical measurement. Okay, so temperature, we read temperature and we have back an electrical measurement. Then we have the sensing system, the sensing technology, which is a little bit bigger or wider because it includes sensors, but it includes also a lot of other parts which make it readable to us. So sensor takes the physical input, transforms it into something that is electrical. Sensing technology takes the physical input and then many steps of transformation, and we can read it and we can use it. Okay? So this is how many sensors we are having these days. Okay? And how it is going on. So you see here you have basically billions of sensors, and this number is increasing. And the value of this sensor market and devices, including sensors, is increasing a lot. Okay? So today we have all around approximately 65 billion of sensors in the world. If we see it from another perspective, and if we want to map these sensors and create a big grid on Earth, on the habitable areas here, so we have 64 trillions of meters square where we can actually live on Earth. This is what we see. So we have basically one sensor every 800 meters square. And this number is going to increase because by 2050 we will have one sensor every 250 meters square, and in 2100 we will have one sensor every 150 meters square. Okay. And this will be again and again the more important data source that we will have, or one of the most important ones. Okay. And with the data we saw that we have AI and very big breakthroughs in AI. Then some other parts. So AI, sensors, sensing technology. Now we enter a little bit more in the health part. Okay. Aging of population. This is one of the main issues that we are facing today and we will face in the future. Just looking to Europe, you see here that from the first, or let's say the first 32 countries with the biggest part of over 65 years old people in the world, okay, only 2 of these countries are from outside Europe, which are Japan and Canada. All the others are from Europe, okay. So we are aging quite quickly, okay. So we have a very big proportion of our population which is over 65 years old. Here is Norway, which has basically almost 1 million of over 65 years old, okay, on a total number of 5.5. Now, the other big issue is that half of this over 65 years old is over 75 years old. And these are the group of people which need a lot of attention from our side, okay? So this is where we live today, and this is the issues that we are facing, in particular here in Norway. We need doctors, we need nurses, we need more caregivers. We don't have these people, okay, because if we want to keep and have the right amount of these figures, we will need to have more than half of the students going out from high school to go into some healthcare-related studies, okay? And this is not what we want to do, okay? We still want freedom to do what we want to do ourselves, okay? This means that since we don't have these figures, the actual ones, they are having higher workloads at work, okay? Long hours, long shifts, and so on and so forth. And this is also why we are going to, and we want to transit from care homes and hospital care into home care. So we want to take care of these people at home, at their home, and they have to stay at their home as long as possible. Okay? So these are the main implications also from an economic point of view. The prices for healthcare services will increase for everyone. These are some statistics from the USA. And more importantly for us here is that we will have a lot of big societal implications, okay, for ourselves in particular. Okay, I don't know if you have ever heard about the 142 issue in China. Okay? Anyone? You know the rule of one child in China? 142 means one child today in China, or one young person in China, has to care about 4 grandparents and 2 parents. Okay? And that's a very big issue that they have there, okay, from a social point of view. And this is why we are now talking about the sandwich generation. I think most of us here, we are the sandwich generation because we are basically millennials, more or less, okay, most of us here. And we have to care about our parents, our grandparents, and simultaneously about our children. So we are in the middle and we don't know what to do first. So to care about our children, to spend our time with our children, or with our parents and our elders or our grandparents. Okay? So this is a big issue that we have to face these days. What are we doing? So we started doing a lot of things. So the first concept of telemedicine in this field arrived, I think, around the 80s or 70s. So, and then we started having technological evolution. We started having sensors. We started having smartphones for remote monitoring and so on and so forth. European Union and also USA started putting there actually a lot of findings, for example, for ambient assisted living. Then we started using what we call the Internet of Things, okay, for healthcare or in healthcare. I don't know if you know what Internet of Things is. Okay, so it's this big network of devices which can connect with each other and which can communicate with each other, and we can use them to implement many different applications. So Internet of Things was there first, then we used it in healthcare, like in this example here. Then we had actually the Internet of Things for healthcare, and today we are talking about Internet of Medical Things, which is a specific research area where we are actually designing IoT networks for medical purposes, okay? So with all the certifications that we need and so on and so forth. Now, what happened here? So let's say, for example, in the ambient assisted living concept. So the idea there is that you create a system or an ambient, an environment where you use technology, and the technology helps these elderly or people with special need to daily live, okay? So to perform the activities. But in many cases, what happens is that these systems were performing the activities on behalf of these elderly. And as it happens when they go in the care homes, their autonomy goes down, okay? So we don't want that, because what happens is that they lose autonomy, but we want to make these people to be self-sufficient, okay? They have to be more autonomous, they have to learn to do new activities. Just think, for example, that a person over 70, they start losing the thirsty need, so they don't understand that they have to need to drink because they don't need it, or they don't think they need to drink, but they have to, okay? So you need to start helping them to learn that they need to drink water. Or the same thing with medications. You arrive 65 years old, is where most of the medical conditions came out. Try to teach a person to take medications every day or every 4 hours. It's very difficult, so you need to teach them this new behavior. Okay, and this is why then we move from assisted and ambient assisted living into active and assisted living, which is a new topic in this case. We want to maintain them active, okay, in an assisted living environment. And this is where we put together AI and IoT. And then we have the Internet of Medical Things, the artificial intelligence of things. Okay, so it's a connection of many, many different things. As you see here, IoT, sensing technologies, AI, and so on and so forth. And in there, you can do a lot of different things. Okay, but I will not stop here too much. I will just go directly now to give more information about this. So this is where we live today from a healthcare perspective. Okay, so just take a look to the right part of this graph. Most of us are up there, or at least from most of you probably are up there. So you are using these systems. Okay. Instead, the technology people here, we are most on the side, on the down part. So we have the cloud centers where we collect all the data and we run AI algorithms. Then we have also communication layers, as you see there, 4G, 5G, 6G in a few years, and so on and so forth. Then we have devices that we normally use, smartwatches, smartphones, tablets, and so on and so forth, which is called the edge computing layer. Okay, and then we have the embedded computing layer, which is what I am more specialized in. Okay, so we have small sensors embedded in daily life. Okay, and the idea now is that we are moving the AI from the data centers, because there we have a higher computational demand, into the embedded computing layer, because there we don't consume a lot of energy, which is one of the main issues. The other thing is that if we have to send data to the data center, we need time to send the data in addition to energy, and to get a response, we need additional time. And in many cases where we have to implement this in a healthcare scenario, we don't have that time, even if it is like 10 milliseconds. We want to have an answer in 1 millisecond from our AI model. So we are developing everything basically here. Okay? So this is the trend, to move all the AI from the data center down here on the embedded computing part. Okay? And this is why we are talking about artificial intelligence of things, because the idea now is to move the AI from there to the things intelligence on the lower layer. Okay? Perfect. So let's move to this one. So how are we using all this knowledge? I know it's a lot of information. Okay? So we are designing, and this, for example, was my PhD thesis that I defended in 2020. we are designing virtual coaching systems with the goal of creating these active and assisted living environments where we want to teach people to perform and to learn new activities that they haven't had to do earlier, and also to avoid unwanted activities. For example, someone who drinks too many coffees, okay? Someone who drinks alcohol, and we want to check it, and we want to tell this person, don't drink alcohol, you know. It's not very healthy for you, and so on and so forth. In my thesis at that time, what we did, we based that work of the virtual coaching system on the extended mind concept, okay, where these authors, Clark and Chalmers, in '98, they said, okay, you know what? Our brain is not only what we have inside here, and our mind is not what we have inside our brain. Our mind is extended to our daily context, to our daily life, to our daily object. Now, I see my bottle of water there. I want to drink water. That's a very simple example. I see, I don't know, an object of daily life that I use, a computer, and oh, that's actually an illness. I need to work now, okay? So this is the idea there. So the mind is not what you have in there, but also the surrounding, and you have to use this surrounding. Okay? And this is what we wanted to do. We wanted to create a virtual coaching system based on AIoT, okay? And using to recognize daily life activities to implement these virtual coaching systems. And I will show some examples of virtual coaching system later. Okay? So these are some examples of daily objects and daily environments. So for example, you see here pill container, the strollers, the plates, the brush, teeth brusher, the hair brusher, not for me, but yeah. Okay? So all these kind of objects, they remind us, okay, that we need to do something. And we use this. They are part of us. Okay? So the idea here is that we wanted to transform all these objects into smart objects, and also the environment, so the daily living environment, at home, at work. It's very important to know where you are, because we can correlate the position where you are with a specific activity, and so on and so forth. Okay? So in this context, we have already a lot of things, because we have sensors. Nowadays, sensors are very cheap, very small, and so on and so forth. Okay, these are very cheap sensors. Just an example. Okay, $2 sensor, coin size. You can have it also smaller. And this one can read the temperature, the humidity, the CO2 level in this room. It can read the movement, and so on and so forth. The light level. Okay, so this is a sensor, and we can buy these sensors in addition to these ones that we have already, or the phone ones that we have already. Okay? So we have a lot of sensors. This means that we have a lot of data. We already have a lot of data analytics techniques, but we are developing more. So what we are doing nowadays, we are implementing new algorithms. So we have data, we have sensors, we need more algorithms these days to recognize specific things. Okay? So this is the starting point for us. What are these human activity recognition systems? These are algorithms, the one that is recognizing your steps on the smartwatch, or the one which is recognizing if you are running or sitting down too much, or I don't know, doing sport activities and so on and so forth, or stairs or laying down. So these are human activity recognition algorithms. So you have a hard algorithm running in your phone, which is recognizing basic activities. How do you design this? Complicated steps, but very summarized. You collect data, very easy, because you need this today, and that's it. You need to do data annotation, not so easy. You need money and time. And then you have the AI part, okay, where you actually train models to design the human activity recognition model. Okay, so nowadays also, it's very easy to create the models. 20% of the time, or the design time of the HAR model is on the AI part. Most of the time you need to spend for the data annotation. You need to sit there and annotate videos about what is happening. When I was at University of Florida, we had the full room of master and bachelor students paid to annotate videos from our test in the hospital. So they were there watching frame by frame and saying, this is what is happening, this is what is happening. Years of annotation, okay? And that is the most difficult part. And we are trying also to work on this part to have automatic annotation instead of manual annotation. And then the data collection is just 10% of the time, okay? Because it's easy to collect data these days. And not only with wearables, but we will see also other kind of sensors later. Okay? And the application scenarios are from different fields. So when I say hard, just to show you, it's not so easy because it's a lot of things that you can manage. So this is a framework that we have designed during the years. Baseline human activity recognition. You see, you have to choose many different things. It's not easy, but we are automatizing these kind of things. In addition to that, we are also working to create automatized system for everyone, not only for us who knows these things, okay, but also for people who is not working, for clinicians and so on, by using low-code, no-code platforms. So basically, you don't see what is happening back there. You just drag and drop some boxes and stuff, and then you have an AI algorithm running, okay? And then you have a lot of already existing other frameworks there, okay? Now, how are we using this AIoT and HAR for virtual coaching systems in elderlies? So as I said, we are using these things, Apple Watches, this is a TicWatch or other Garmin watches, Fitbits and so on, to recognize our activities. And what they do, they have human activity recognition AI models inside. But these activities can recognize basic things like walking, sitting, running, number of stairs you do every day, heart rate, even if in this case most of them are not very accurate, and so on and so forth. Okay, but if I go to the hospital and I talk to people working with elderlies and people working with mild cognitive impaired people and so on and so forth, they say, yeah, I don't need to know how if they are just walking. I need to know more specific things from their cognitive and functional domain. For example, I need to know if they are showering themselves. I need to know if they are washing their hands or if they are washing their teeth in the morning. I need to know if they are doing laundry. I need to know if they are eating or cooking and so on and so forth. I don't know who is from here from the health-related areas. You know, municipalities, they call these people at home daily or once a week or once a month and say, have you been regularly eating? Have you been washing yourself? And they have these questionnaires that they need to fill out, the AIDL and PADL questionnaires, okay? And these questionnaires are the questionnaires that then clinicians use to make decision or diagnosis, okay? But they can do it only once a month or once in 6 months, and that's not enough to be done, okay? So we want to automatize this type of knowledge with HAR models. So we know every day if they are doing these activities, and this will permit us to have early intervention in people who are at risk of mild cognitive impairment, for example. Okay, or people who are having a functional decline, so municipalities can go and say, okay, look, we see a higher risk of falling down from here in 2 weeks, so it's better if you start to do some physical therapy, okay? So the existing solutions are not able to do this, okay, because of the limitations of data, automatized data, and so on and so forth, and we are working in this direction. For example, as you see, using sensors and smartwatches, we transform daily life objects into smart very easily, and we can understand the connection with this or the interaction of people with these daily life objects by using sensors and AI. So we have AI in the smartwatch, we have AI in the small sensors in this case, which interact together and can tell us more information and automatize this human activity recognition pipeline. Okay? This is a small example from the Healthy Campus Founded project, Smart Objects for Smart Care. And this is the system that we have designed. As you see, we can understand, first of all, where in the house the people are. So in which area, bedroom, bathroom, bedroom, kitchen, living room, and so on and so forth, very easily. And we can also understand complex activities. If they are eating, if they are cooking, if they are preparing the meal, if they are reading the newspaper, if they are wearing their shoes, and so on and so forth. Okay, so it can sound weird for someone or dangerous, but it's very important for healthcare providers to know this information. And the idea here is that all these things here are not taking place in the cloud or in an AI center. They are taking place here. So we send only basic information. We don't send any other sensitive information or whatever. Okay? So this is a platform that we have designed, and we are using it, and we are still building. We need a lot of time and fundings, and Babak knows this, how much we are applying for fundings in these kind of projects. Okay, so yeah, another use case of the virtual coaching system. So I think everyone knows Parkinson's disease, but I think few of you know specific symptoms of Parkinson's disease. So this is one of the main symptoms, motor symptoms of Parkinson's disease, which is the freezing of gait. You see this person? This is a Parkinsonian. He's walking and then he's blocked. He's blocked because of the freezing of gait. He doesn't want to block. He's there. His brain says, move on. His feet don't answer the command. So they try to move on with the upper body. Okay, so the things are they unblock or they fall down because of the imbalance of the body. Okay? Where does it happen? It happens when, for example, there is a narrowing, where is a pattern change on the floor, a color that distracts them, because the problem is that with Parkinson you lose the multiprocessing of the brain. Okay, so if you are distracted, if you hear a sound, they will get distracted and they will have this kind of symptoms. Okay? Now, how can we help them? Yeah, definitely medication, but medication over time, because this is a lung disease, loses its ability, so you need more and more and more medication more often, so on and so forth. Or you can give them external stimulations, okay? So you can give them visual stimulation, you can give them tactile stimulation, you can give them audio stimulation. Military march, 1, 2, 1, 2, and they will keep that in mind, they will be concentrated on that task, and then the external issues or the external factors will not be so important for them, okay? There have been a lot of approaches. For example, you see here visual stimulation. They put lasers on the shoes, and the laser is going to point where the next step will go, okay? So they have that as an indication, so they are like, but that's not good when you go out, because people will start starving at you, like, what is this guy doing with these lasers? Okay, audio stimulation, headphones, and you have a continuous beep on your head, like beep, 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 and that becomes very annoying over time, you know. And so now we are working a lot with AI, not a lot of research, not only me, okay, just to be clear. So this is what we are trying to do, to create virtual coaching systems which uses AIoT, so sensors and AI, to implement HAR models, okay? And we will see some examples. So for example, what we did here, we created, because it's a complex disease, it's not say that to recognize the fog, we use sensors. It's not say that you can do it with one sensor. It can be that you need 10 parts of the body to recognize the movement, okay, or to anticipate the movement. So you need to collect a lot of data. For example, we designed a body area network, a low-cost one, okay, compared to existing systems, which integrates 12 sensors that you put on the body, okay, and then you can collect data from the arms, from the legs, from the ankle, from the back, and some from the head, and so on and so forth. And with this data, then you design HAR models, okay? I will go just here. So this is an example. So this is the same video that we have earlier. Now, if you see here, this subject had something here. It was basically a board with a sensor. The board was collecting the data from the sensors in the shoes, okay, in this case, and from the arm. It was implementing an AI model, a HAR model, which was able to predict the freezing with 2 seconds of anticipation, okay? And as soon as it predicts the freezing, it starts vibrating, okay, with the frequency of the movement, okay? And then the person there, you see, moves straight forward in this case. However, this is a very good patient, a very good subject, because you can see subjects that are very advanced in the disease, the system doesn't work, and so on and so forth, okay? So this is another example. This is another project that we are working on. It's still in prototype mode. We got some fundings and also from Helse Campus again. Now, I already spoiled it, but this is smart glasses, basically, okay, with sensors capabilities and so on. This is a very preliminary prototype. But the idea here is that these smart glasses will be integrated into the life of a Parkinsonian, okay? And then it will be able to monitor different parameters, motor parameters, physiological parameters, heart rate, oxygen level, speech, and so on and so forth, to try to recognize symptoms and the evolution of symptoms, which is actually more important. Okay? Again, quite small. We are designing this in-house, basically, with a PhD student working on the software and some external people working on the hardware, because we don't have that knowledge. But yeah, so the idea here is that we have a tool that can monitor daily life, can give information, can give, for example, stimulations, can give medication reminder, and can help the clinician to recognize daily activities. Why smart glasses? Because based on what we have discussed with Parkinsonian people, they are like, yeah, I would like to have smart glasses instead of a wearable or sensors all around my body. Okay, so it's one of the most used or most accepted wearables that you can have. Okay, another example, again, related to elderlies and workers. We just got the Best Paper Award in a big conference, the Design Automation Testing in Europe conference a few weeks ago. Falls, okay, so you know most of the works or systems which recognize falls, they recognize the fall after the fall takes place. So you fall down, then the alarm is raised and someone will come and help you. But the injury already took place. What we wanted to do here, we wanted to recognize the falling phase. So from when I start falling before touching the ground. And then what we did, we designed the jacket, in this case, with an external company, which includes some airbags. The airbag time to open, from trigger to open, is 150 milliseconds. The falling is very short time, so it goes from 100 milliseconds, when it's a very fast fall, to 1.5 seconds, not more, or if you don't fall from a very high level, okay? So this problem was a very big problem, also for AI part. So we designed a jacket with sensors inside, so we had the smart jacket, okay? And then we collected data, okay? We designed the AI algorithm, which is implementing this thing now here. So this is the scenario, okay? So it starts falling because it works also for workers, okay? And as you saw, it opens. So I have other videos, but this was like the best one, okay? So which is the nice part here and the difficult part. So first of all, this AI model that we created, this convolutional neural network that we created, the size of that network is around 67 kilobytes. So basically less than one message that you send on WhatsApp. Okay, so when you send a message on WhatsApp, it will take more memory from your phone, that AI model. It requires only 16 kilobytes of RAM from memory from your phone or from your, in this case, actually, it's nice because that algorithm runs basically on this chip here. Okay, so very small one. And it requires 16 kilobytes of RAM. And the time that it takes from the moment we give in input the data to the model to the moment then the model says falling or not is 4 milliseconds. So 4 milliseconds, and then you have enough time to open the airbag. Okay? So this is another example of hard models for elderly or workers, okay? However, this is not all, because we are trying to move forward. Someone says, yeah, I don't want to use wearables, okay? I don't want to have anything in my body, in particular if you go with elderly people or people with dementia or mild cognitive impairment, okay? So they say the smartwatch, what is this? They throw it away, it's not mine, okay? So we want to do something more, and there are a lot of other future hard and sensing technologies out there. One of the things that we are working on is radio signal-based sensing, okay? So this is it. In this room, we have an access point somewhere. So we have an access point which is emitting the Wi-Fi signals that you are using to connect with your wearables and smartphones and so on. So the Wi-Fi signals are signals that go from the access point. If the environment is empty, nothing is changing, okay, or moving, what you will have like the effect of throwing a stone in the lake, and you will have this very nice and smooth waves moving around, okay? But as soon as you put the finger in the water, and these waves will be destroyed, okay? The same thing happens here. You have the Wi-Fi signals, you move around, you put a new object somewhere, and then the wave will be distracted, okay? Then we can measure this change in the wave pattern by using, in this case, a Raspberry Pi, so I think $80 of device, okay? And we can recognize these changes, and we can associate the change to a specific person, to a specific movement, raise your hand, running, walking, and so on and so forth, okay? And other kind of things. This is a video, okay, from Christian. He will get the PhD next week. He's one of my PhDs in Italy. Okay, so this is a description of what I said. You can use it in different things. So this is an example. So you have an access point. This is a tool, Wi-Fi, that we designed. It's open source. As you can see there, every time he breathes, you will see that change of the lower antenna 4 there. You see? He breathes, and you can see that specific movement of your chest. Okay? You move around, you sit, you walk in a room. Imagine this setting in a care home where an elderly is living. The elderly has their own room. They can stay there and they can stay on the bed, they can move around, they don't need wearables. You can just recognize what they are doing, the walking, the sitting, the eating, just by using the Wi-Fi network of the care home, okay? And other kind of activities like recognition of specific movements. We are also working with other technologies, again, radio-based, for example, millimeter wave technology, where you can actually also recognize the heart rate, okay, the blood pressure, and these kind of things. The sleeping phases of the person, and so on and so forth. So very, very specific information, medical information in this case. Okay? This is the tool. If someone of you wants to play, just go. This was published at PERCOM, one of the biggest conferences in pervasive computing. Okay? And it's easy to use. I don't know. Hey, you want to use this? I don't know if the others have the knowledge, but it's very easy. It's very well documented. You just go there, and if you want to see what your neighbor is doing, try to do this. Okay? And the nice part is that this tool has the capability in one tool to have all the radio part, but also the AI part. So you collect the data, and the tool can automatically train an AI model which will be able to recognize what is happening. So you have a HAR model which is taking in input radio waves and is giving you an output walking, sleeping, sitting down, running, and raising the hand, and so on and so forth. Okay? So this is the GitHub page. So this is how the tool works, as I said. So those are Wi-Fi or radio signals. Instead, this is what the AI part is saying. Okay? You can implement multiple models, multiple AI models there, and you can have compare them, how they work, and so on and so forth. And it's saying to you basically, for example, green means very probably 99% this is the activity this person is doing. Going towards red, it means not that activity, and the level means the type of activity. Okay? A lot of other scenarios we have been using over the years. So, as we said, Parkinson's disease, daily life activities in people with Alzheimer. We started also working with wearables with women who have gone through chemotherapy, but after chemotherapy they have the chemotherapy-induced peripheral neuropathy, so they start losing the sense in the fingers, for example, or on the feet. So if they put the hand on a very heated area, they will not feel it, so they will get burned, and so on and so forth. So we want to avoid these kind of issues, and we are using wearables for that. Virtual coaching, as you said, for example, we have some works where we teach elderly to drink water or to take medications, and so on and so forth. Safety in Industry 4.0, we have in my old university in Verona, we have an industrial plant, smart industry plant, where we have all these kind of things for workers, where we monitor workers, how they work, and if they are in dangerous situation, if we see their progression, functional progression during the days, if we see some decline, we say, okay, pay attention, don't go at your workplace today because you can have some issues, because we see you're not doing so well, and so on and so forth. And then, yeah, this is something that we are working now, human digital twin, so to have a digital twin of the human based on the daily activities they do, and so on and so forth. So many other things, and basic things like indoor positioning to find out where you are in the house. Okay, all of this using sensors, but we are trying also to move a little bit more on the radio-based part, because not everyone wants to use wearables, okay? because you need to buy it, because it's more uncomfortable. You don't like smartwatches. You are old-fashioned. You want a normal watch, and so on and so forth. Now, all of this is not only from me, definitely. It's from a lot of people, a lot of students, master, and so on, a lot of PhD students, and a lot of collaborations. These are all universities I have been visiting, at least, so around Europe and outside. So yeah, so that's it. Hope it was understandable.